Hey, fellow astronomers. This is Rock Mover here. Just wanted to give a quick overview of the TeleViz software I just wrote. I literally just started this last Friday. It's now Tuesday afternoon. I think it's fairly close to being finished. So I'm going to post this for you guys. Just wanted to, well, too lazy to write a user manual, so it's easier just to make a quick video. So that's what you're getting here. This is your user manual. The installation, it'll just be a zip file and unzip it anywhere you want. There's no installation. Essentially what's in here is the actual executable. This is the program itself, a whopping 100K. There are some Sharp DX DLLs. These are required for the graphics. I'm using DirectX 11. This is a port of DirectX 11 to C Sharp. I actually wrote all this in C Sharp, done by Alexander Mutel. Hats off. He's a great guy, and this was an amazing product. He did a lot of work porting this, the DirectX to C Sharp. But anyhow, so that's what that is. The shader, that's actually for the DirectX as well. I talked directly to the video card, so these are actually the shader functions of how things are being shadered and textures and all that kind of stuff. You should never need to touch that. The man DLL, that's simply, there's a man that you can show in there. That's just the triangulation for him. I didn't want to embed that data in the executable, so that's just there. The config file, this is important. There are 4 telescopes that you can adjust, and it basically just loads this config file when you start, and when you say save, it saves this config file. So if you want to share that, you can, rename it, copy them, save backups. Maybe at some point I'll make it so you can open any INI file or whatever, but for right now there's just one, and that's it. And then the ASCOM DLLs, I'm not sure if I need to distribute these, because if you have ASCOM, I believe it'll automatically find them. But they're tiny, so I'm just going to throw them in there. So basically, these are the files that you get in the zip. You just unzip it, and there you go. You just run it. When you go ahead and run it, it's going to, of course, ask us for our telescope. I'm going to just connect to the Plano telescope hand controller, whatever that's called, and there we go. And it should go ahead and just bring up this exact same window, because you're going to have the same config INI file that I'm using right here. So in a nutshell, all this is it just shows you a pretty picture of your telescope. The hope is that you guys just can put this up in the corner or do whatever you want, and it sits in the corner while you've got all your other stuff, and depending on what telescope you want to look at, and you can see where your telescope is currently pointed at and what its orientation and configuration is. So that is all it is. As far as the settings in here goes, I've tried to make it really configurable. Again, we can just select different up to 4 telescopes you can save. I'll just run through these really quick. Telescope name, just name, does nothing. The gem distance, this is really important. This is actually probably one of the most, or the most important. I kind of tried to make them a little bit in order of importance. But this is actually defined if you go into your path controller here, and we go into setup, and we look at this, you'll see if you show the dome stuff, this is essentially an offset in the X, Y, Z of your pier. You enter your dome radius, and you enter this gem axis offset. So I could technically grab this from from ASCOM, but I don't. You have to enter that information here. But again, all it is it's the distance from the center of the rotation axis here of your right ascension axis to the center of your telescope. So center to center, it's literally that distance right there. So that's important that you put in there. Clearly the telescope diameter, if I change that to whatever I want and update, I get a bigger telescope diameter. Telescope length, same thing, pretty self-explanatory. It is the length of the telescope. All of the colors, any of the objects here, for example, if I just click on telescope color here, I can go ahead and pick it and change my telescope color to orange or green or whatever I want. Ultimately, I wouldn't mind playing around with some texture mapping, and so you could actually map in like a cool looking telescope and that sort of stuff. But for right now, you can just change all the colors. So that's all pretty self-explanatory. The telescope CG, put that at 0, and I update. it just simply puts us at 0. If it's anything other than 0, it's measured from the back of the telescope. So in other words, if I put in 5 here, you can see it's 5 millimeters from the back, or 200. So that is that distance there. There you go. Pier color, who cares, it's pier. The pier height. The pier height is to the top of the pier where your mount starts. So none of this in here counts. So it's literally from the ground to the top of that pier. I did that on purpose to make it easy. Pier diameter. If this is less than 3 inches, less than 80 millimeters, it'll assume it's a tripod. So I mean, if I put in 100 here, and sorry, you got to keep updating every time. Yeah, I can't imagine you having a pier smaller than that, but I also can't imagine your pier legs being 4 inches or more in diameter. So if this is, say, 75, once it's less than 80, it automatically switches to a tripod. So that's what switches. Maybe I should have an option button. It's just the way I've done it. The pier top, clearly this is the pier top. Again, pier height goes to the top of this. Top diameter, exactly what it is here. Change that to 200. I mean, clearly you can go through and change all these yourself, but I'll just go through them. The top height is just the height of this. Again, the top where the mount is at, that's the pier height. So by changing this number to 300 or whatever, it simply changes where the legs are coming up at. So you can change that and make your legs come up exactly where they intersect. Somebody correct me if I'm wrong. The legs I currently have at 30 degrees, I think that's right. If not, we can clearly just add an input for the angle of your tripod legs if you want. Super easy to do. The mount, also 3 inputs. Tried to make it really simplistic here. Just the width is the width, basically the diameter, if you will, of that. Also same as the diameter of this. I just made them both the same. But this vertical and longitudinal distance are kind of important. I'm going to just make this like 25 just to make this simple so you guys can understand. There you go. Here's the vertical section. Almost all mounts have something that it comes up, and then you adjust your latitude on, so you've got that distance from there to where it starts to bend. And then the latitude distance, I just call it vertical and latitude. So this is a vertical, this is a latitude. Obviously, I want that as a distance because if you have different latitudes, your geometry doesn't change, it just does automatically. So if you put this in once, you're done. The pier, it does grab your latitude from ASCOM, so you don't have to enter that. So that's automatically entered. Go back to, what did I have, like 100? Yeah, that looks reasonable. Again, the distance from the center of this to the center of your telescope is already set by this gem distance. You set that, subtract off the telescope radius. I added a little bit, you can see here, for Los Mande mount, which is currently round. Maybe I'll make that a long bar at some point to make it a little bit better, but I basically set that. And that sets what's left here is what's going to be left, and I simply make that symmetric around the other side. Counterweights do absolutely nothing except for a pretty picture, pretty self-explanatory. Ooh, counterweight is spelled wrong there, oh well. We'll make that 200, and you can see that simply changes what the length of your counterweight shaft is. I don't think it gets any harder than that. The counterweights, obviously, you can have up to 3 counterweights. They'll have to be the same counterweight diameter. Sorry, I've just entered that once. The distance is from the end of the counterweight. So if I put in 1 here, that gives you a 1 millimeter gap from there to the counterweight, not to the center of the counterweight, because then if you put in 1, it would actually be hanging off, so it doesn't really make any sense. So physically, and it's easier to measure counterweights from the face of it to the end of your shaft. So if you put in 25 there, that gave you 25 millimeters from there to there. If you only have 1, simply put in 0 for these, and you're done. There you go. Now into the back of the telescope, focus or diameter and length, same thing. That's just this purple thing here. Filter wheel, same thing. Camera color. The dome, if you want to show the dome, you can certainly show a dome on here. Go ahead and set the dome. There's my dome. By the way, obviously, right now I don't have any debugging. If you put in an Apple here, and you, and you hit update, it is probably going to crash on you because I simply convert the value of this, do a convert to a single floating point number. So there's no error checking in here, and that's why you have to actually hit hit the update button. So that's not true with the camera colors. If I go ahead and, or any of the colors, if I click my dome control and click OK, you can see that will change immediately. Dome diameter, the opening width. This is obviously the opening width of the door, and the height, all pretty self-explanatory. If you don't have a dome, just hide it. It's got cool transparency effects, wireframe effects. I'm still kind of playing around with that to see what I really like. The whole point of this is actually I'm writing a dome control software. I've already got it all done. It's working, but I'm porting it to an Arduino, so people will be able to download that, and it'll be pretty much dirt cheap for you to implement your own dome control motors and encoders and whatnot. So that was the driving force behind all of this. Sky color, background color, floor diameter, plus or minus. If you use a negative value, it just gives you a square floor, and positive value gives you a radius. Mr. Astronomer here, if we want to show our cool astronomer guy, there he is. There's our cool astronomer. We can even color him funny colors. Again, I got some texture issues going on when I exported this to STL file. I can see my vector normals are negative there, but at some point I may clean him up or make a cool little guy. He just was something I had laying around in a file with some other stuff I was working on, so I threw him in here. The arrow, that is actually sort of important. There is a arrow that always points north. That's just for your own reference. Information, yep, if you want to show the info or not, right there. Ideally, the ultimate goal of this, go over to one of these other configurations, is that when this stuff rotates around, I actually want to be able to tell you how close you are to any of your camera or any of the equipment hitting the pier. So that's kind of the next thing I want to start working on, is just calculating that, which actually shouldn't be too terribly difficult. You can just go through object by object and find the closest distance between them, and yeah, so that would be a very, just I guess, handy, cool little thing to have. So that's about it. Oh, by the way, if you right click gives you pan, zoom, rotate. Again, I'm just now left clicking. Personally, I just always leave it on rotate. The middle mouse button, the wheel scrolls in and out, and it's a smart scroll. This takes some coding, let me tell you, in the DirectX, but the point is wherever my mouse is at, that's where it's actually going to zoom in. So if I'm up here and I mouse wheel, it zooms in that corner. If I'm down here, it zooms in down here. If I'm on the top of that arrow and I zoom in, as I kind of zoom in, I can zoom in right on that arrow. So that's, once you get the feel for that, a lot of programs kind of use that methodology. I think I've actually implemented it pretty darn well here, that looking at where that vector is at. So you can right click and do all those, but once you get the hang of it, you pretty much, I just leave it on rotate. When I want to zoom it around, I just, okay, where do I want to go? Save telescope view, obviously just saves the current view. So if I move this around, I got it all screwed up. If I right click and now say restore, it just restores that view. Save window size and position. This is kind of a nice one. So if I actually resize my window, or I want to put it at a certain point in the screen, I can go ahead and save that. And when I want to restore it, I just come over here and say restore window size and position, and it puts it right back where it was at. So you can save that in a spot on your desktop or wherever you want it, which is kind of nice. The dome control, like I said, that's all in the works. Hope to have that finished shortly. And I think that wraps it up. I don't think there's anything else. If anybody's got any questions, just drop me an email, post them on the forums, and we'll go from there. Hopefully you guys find this useful, and have a great day. Cool.